Hello and welcome to this tutorial. Today we did a model of the fire analysis, thermomechanical analysis of a timber wood beam here. This is a timber wood here. We used thermal properties plus mechanical properties for this timber wood. And first we did here the heat transfer analysis. Here it is the heat flux, it is not important, the temperature. We apply the temperature on the bottom surface of the timber wood and you can see here as a fire condition. Also the radiation, we applied the convection as a fire and radiation. Also here the conduction happened in the beam. You can see here is the maximum, here is the minimum. The maximum minimum is around 10, 5 or 6 degree because we use 2 hours here. This is the time 2 hours heating or applying heat to this timber wood beam. You can request, for instance, nodal temperature or anything, heat flux for the beam, but this is the thermal analysis and we just need the temperature or nodal temperature to do the bending test in the static model. Here we have the static model bending. In this model, we consider the temperature as the initial condition as the nodal temperature to create the stress in the node. Also, we apply the bending here. See, click on this, and if I request, for instance, temperature, you can see the temperature. This is the temperature from the previous model. Also, we can check the yield criterion here. You can see these red areas is the failed area because the yield strength is reached here and they don't have any capacity. Here we can consider this as a failure zones. Here let me click on this, see first, and this is the second, and let me check, for instance, the stress. See here, first we have thermal stress and then the bending happen, and this is the stress. And we can request plastic strain, we can request plastic strain equivalent, displacement, shear stress or yield criteria or anything else. Also we can request force displacement diagram. Here we have a little bit weird thing, and that's because of the nodal temperature and the stress which is come from the temperature. And after that we have increasing capacity. Here we have a flat line, and if we keep the bending and displacement, it reaches zero value for the force, but the maximum capacity is around 3.2 kilonewton for this beam. Okay, so if you want to do the fire and bending test on the timber wood beam like this, to consider full behavior under the fire and mechanical load, you can provide this tutorial and we put it on our website here. This is the tutorial here. Come to our website abaqusfm.com, find the English tutorial here, click on the title, then you will have the geometries, material, step interaction, load, and then the result as figures. You can see that. The file contains CAE, INP, reference paper, English video step by step. The cost is 30 euros. Notice to this point here, we provide the original tutorial. Maybe some guys do some copies, but they can't answer your questions. So if you want this, you can use a PayPal, Visa, or MasterCard for the payment. Before that, contact me to this email. Also, we have a full package on our website here. Contains more than 400 tutorials about all things in simulation and modeling. And if you provide this tutorial, you will be a master in Abaqus. You can do anything. These are the main titles that we have in this full package. You can read them, and also many subtitles and many other tutorials besides these main titles. You can see that. And each file contains a INP English video file, a step-by-step video, papers, and you can buy it here for a very affordable price, and that is so good for the students. If you want this full package to learn Abacus deeply, contact me on this email. Thank you for your attention.